So today we are working on solving a differential equation where both of the solutions to the differential equation are the same value, aka if there's like a double root. So we're going to start with our example problem, which is number 10. So the second derivative of y minus 6 times the first derivative of y plus 9 times y is equal to 0, with the initial conditions that y of 0 is equal to 0 and y prime of 0 is equal to 2. So starting out, we have that r squared minus 6r plus 9 is equal to 0, where here we are subbing r for y prime. Next, we can factor that into r minus 3 times r minus 3. As you can see, that means that both of the solutions to r are r equals 3, which is a double root. From here, we can conclude that y of t is equal to c1e to the negative b over 2a times t plus c2 times t e to the negative b divided by 2a times t. This is from the quadratic formula and our theory on differential equations. As we can see, negative b divided by 2a is equal to, in this case, negative 6 divided by 2 times 1, as our a value is only equal to 1, which is equal to 3, positive 3. We already got this from the roots, but this is just to show you that this is the same thing. And the reason why this is the same value as the value that we got from r is because of the quadratic formula, where we have the discriminant, which is the b squared minus 4ac part, is equal to 0, and therefore we are left with the negative b plus or minus 0 is the same thing, divided by 2a. So next we're going to solve the initial value part of the problem. So we have y is equal to c1 e to the 3t plus c2 times t e to the 3t. Y of 0 is therefore equal to c1 times e to the 3 times 0, which is equal to 0, plus c2 times 0, e to the 3 times 0 power. From there, we know that e to the 0th power is equal to 1, so we are left with c1 plus 0 is equal to 0. From this, we know that c1 must be equal to 0. Next, we are solving with y prime of t is equal to, and knowing that we have c1 is equal to 0, we can immediately cross that out and do plus c2 t times e to the 3t power, which is now our y function. Taking the derivative of this, we are going to need to use the product rule. Now the product rule is take the derivative of the first and leave the second one alone, plus the derivative of the second and leave the first one alone. In this context, that means that we are going to take the derivative of c2 times t, which is equal to c2 times e to the 3t, plus, and then the derivative of the second, which is the derivative of e to the 3t, which is equal to 3 times c2t times e to the 3t. Plugging in our initial condition of 0, we get that y prime of 0 is equal to c2, which is equal to 2. Therefore, we have c1 is equal to 0 and c2 is equal to 2. From this point, we can write our equation. Now we know that y is equal to 2t times e to the 3t power. Now we can graph the solution. Here we have the graph with the y and the t-axis labeled, which is an exponential function. This graph will pass through the origin point because we have a multiple of t in this equation. As t approaches infinity, we know that y will approach infinity. We can see this visually on the graph, but we also know this because the solution of r are both positive. Thank you.